to help the environment at the same time to stop the usage of virgin resources. Once we start application of these waste materials, reuse, recycle, then definitely there will be possibility of saving our nature. So here, if you look at the classification of today, I'll focus more on the industrial waste and application of it. That so, if you look at the classification of industrial waste, generally we call it as ISWS. According to their nature, it is classified into two types. There is organic industrial solid waste, inorganic industrial solid waste. According to pollution characteristics, hazardous waste, non-hazardous waste. According to the industrial sectors, mining industry solid waste, metallurgical industry solid waste, chemical industry solid waste, food preservation industry solid waste, construction industry materials solid waste. So till now, I was working on mining industry solid waste, and now I started working on even construction industry waste, like we simply call it as a construction demolish waste, CDW waste. Okay, so that is also there is a wide scope. If anyone is interested, we can work extensively on this construction demolish waste because a lot of construction is happening, a lot of demolitions is also happening. So how to use that waste that I started working recently. So, but in this session, I'll focus my research on limits to the mining industrial solid waste. And another kind of waste is according to industry's process, that is a fired, unfired. That is again another type of waste. So the industrial waste is basically classified into four types according to the nature, according to the pollution characteristics, according to industry sectors, and according to the industry's process. So here, basically, I'll be discussing more on the material called red mud. So red mud is an industrial waste. Just a second. Just a second. Yeah, so I'll be discussing more on red mud, which is a industrial waste. This red mud is produced during the process of extraction of aluminum from the bauxite. Maybe few of might have already worked on this red mud. So this is a major waste which is produced during the extraction of aluminum from the bauxite. So the slurry insoluble waste produced during the wear process is referred as red mud, or it is also popularly called as bauxite residue. It is a mixture of non-aluminum compounds originally present in the parent mineral bauxite and of compounds formed or introduced during the various process cycle. So it has combination of the materials which are present as a parent material, that's a bauxite, and the surrounding soil. And also during the process of extraction, during the process of extracting the aluminum from the bauxite in the base process, we induce a lot of other chemicals and catalysts. So because of this catalyst also, there is a waste generated. Okay, so it's a combination of both parent material and the process material. The base process, which utilizes bauxite as a raw material to extract aluminum out of it. So here it is explained Bayes process. So idealized flow sheet of the Bayes process for the treatment of bauxite ores. So once the bauxite ore is mixed with the, I mean, first they make it into a small powder, then it goes to the process of digestion by infusing lime and NaOH, sodium hydroxide, with the process of steam, then washing, filtration. So during the filtration process, the waste comes out is called as red mud or bauxite waste. So why red mud? So there are so many industrial waste. Today I'll be even discussing on iron ore tailings, GGBS, fly ash, all these materials. Also, I'll explain you what are physical and chemical properties of these waste and how it can be applied in the construction of roads. So why red mud? The disposal of red mud remains an environmental concern all around in the aluminum producing countries. Not just India, even developed countries are also facing the problem how to dispose this industrial waste, because the reason is it is hazardous in nature and it is very fine particle size. So these two things makes it's a big challenge for the industries. The amount of red mud getting generated continuously is around 1 to 1.5 tons per ton of aluminum, and twice that amount for every ton of aluminum metal produced. So as per the research, for the generation of 1 ton of aluminum, 1.5 to 2 tons of red mud waste is generated. Globally, 70 million tons of red mud is generated. In that, India contributes about 5 million tons. So if you observe, 5 million tons of red mud is generated per year. Very limited efforts have been made in various parts of the world regarding the utilization of red mud as a material for construction. Limited study has been carried out to find geotechnical properties of red mud, particularly information about the Indian red mud. So even though you can search a lot of articles on red mud, but when it comes to Indian red mud and particularly specifically focusing on geotechnical application, it is always eliminated. So the production and utilization of red mud globally, if you observe here, the figure on my left hand side, it shows that the production in million tons of red mud production annually, it is more than 85% in China, around 30% in Australia. Brazil contributes around 10%, and India contributes, as I earlier said, 5 to 6%. And have, I mean, 5 to 6 million tons of red mud annually increase. So here, the next figure is very important figure. This figure shows you what is the production and what is the utilization. First of all, aluminum production, which indicates the blue bar, and bauxite residue, which indicates the red bar, and the green bar, present utilization million tons per year, and the green bar indicates what is the present utilization from different aluminum production units in India. So if you observe here, Hindalco Utkal, Hindalco Belgavi, Hindalco Muri, Hindalco Raincoat, Vedanta, Lanjigal. These are the different places I collected the data to present what is the aluminum production, what is the waste production, and how much of utilization is currently happening in these industries. So here, if you look at the chemical composition of red mud from different different industries around the world. India, if you look at the chemical composition, India, when you look at the Malco, it is a 45% Fe2O3. Hindalco, it is 35%, 35.46%. Fe2O3, Balco, 33.80%, and Nalco, 52.39%. Among just in India only, we have different types of red mud is generated. Okay, so when you look at the chemical composition, just in India only, we have different compositions. So it is very important to understand the detailed chemical composition, chemical properties of the red mud, which you collect and before using it in any application. Because we cannot say that someone has done a research on a particular red mud, so I'll continue with the same red mud properties. Definitely no. Because I think geotechnical engineers can acknowledge or can accept my words like soil differs even just in 1 meter, 2 meter difference. Also, soil will differ. Same way, this red mud is also different in different units and different times. Even myself and my colleague did research with the Hindalco Belgavi red mud. So even the red mud, when we collected red mud on the top, okay, it has a different properties. After 3 meters depth, it has a different properties, and after 3 meters depth, it's a different property because they dump it as a huge heap. Okay, when they collected it when they dump it as a huge heap of red mud, and when we dig and collect into bags of different layers, different layers has different properties. That is one thing which was really surprising for us. And even one of my colleagues worked extensively on different depths of red mud storage has different properties and different effects on the utilization. Okay. So when it comes to major problems, I'm here simultaneously giving hints where you can work in future because there are a lot of places where still people are not working effectively. So a lot of scope for you. If you are interested, you can just note down my solutions. You can work on that areas. Okay. So the major problems here is disposal of red mud takes huge land. I'm sorry, someone raised a question. Excuse me, I'll answer all your queries at the end. Chaitanya sir, is it okay? Can I answer at the end or you want me to answer right now? Someone raised. Chaitanya sir or organizer, do you want me to answer now or later? Okay, I'll answer later. Fine, thank you. So disposal of red mud takes huge land and disposal in sea affects aquatic system, tendency to fly in air, high pH. The pH of the red mud is very high. We know if the pH is very high, it is not safe and it's toxic, and it has a lot of toxic metals, radioactive particles, groundwater and surface water pollution upon leachate, low strength, and spends 2% to 5% of total cost of aluminum production for the disposal of red mud. When I interacted with uh, this aluminum industries, when I interacted with the aluminum industries, I came to know that they spend around 5%. Here, though I mentioned 2 to 5%, but they mentioned clearly that they spend around 5% of the income generated to just dispose this red mud. Even 5%, sometimes some workers said that 5% is also not sufficient, because sometimes they need to dispose into, they have to take the material for a long distance and they have to dispose, dump it and cover up. Because the open area dump, nobody accepts. Okay, and even when we try to carry this red mud from Belgaum to here, we face a lot of issues like we need to take an environmental pollution board approval, and even every check post, police will stop you on why you're carrying this material when you're taking in bulk. I'm talking when you're taking in bulk. Bulk in the sense one, maybe some 2 ton, 1 ton, that quantity I'm speaking. Okay, when you're just carrying one, maybe 50 kgs, 100 kgs, nobody worries. But when you want to do extensive research, you need a lot of need red mud, and particularly when you want to apply in the geotechnical, yes, definitely we need lot of red mud. And the present uses of red mud are usage of red mud has been made in preparation of building materials such as ceramics, glass ceramic products, fired and non-fired bricks in concrete. Even people started using this red mud in concretes, as we all know. We researchers who did extensively on fly ash, and finally nowadays fly ash is used by many companies in their mixing of concretes or manufacturing of cement. Many places they are using the fly ash. Okay, so definitely the research what we do definitely contributes to the industry if it is really acceptable. That condition is acceptable. Next one is present uses like bulk fill material, application in pollution control like wastewater treatment, treatment as a coagulant, as adsorbent and catalyst, recovery of metals, soil remediation, treatment as a material in cardboard manufacturing, and soil stabilization. Here is the literature review. So I just for the benefit of audience, just I presented here a brief literature review. Extensive literature review, though I have done, I have grouped the literature review into 5 categories, like literature review on properties of red mud, environmental aspects and pollutions of red mud utilization, study on stabilization of red mud, current utilization of red mud, application of red mud in road constructions. So if anyone is interested of any part, if you want to know more, you can contact me. At the end, I'll share my mail ID. You can text me or you can mail me. I can help you to get enough information on this slide. So this is the literature review, which I just presented here. Next, identification of gap in the previous research work. So all the studies highlighted that red mud exhibits good geotechnical properties, which ascertain that it is practicable to use in geotechnical engineering applications. But the high alkaline nature poorly endorses red mud as a recyclable material or renders it not a suitable for natural resource materials. Though many studies says it can be used extensively in geotechnical applications, but at the same time, when you look at industry perspective or when you look at the government perspective, how safe, the question mark comes, how safe and how sustainable. Okay, these two things are which needs more attention. How safe and how sustainable. Because we are talking about sustainable constructions. It's not just using some waste material. At the same time, it should be sustainable for a long time. There definitely there will be a question. We are using proper virgin resource materials that only not sustaining for a long time, then how can a waste material can be sustainable? Definitely, I think this FDP will enlighten you how the different waste materials will be a sustainable material if you apply in a proper mold. The issues mentioned above ardently emphasize the necessity to develop holistic approaches and sustainable technologies that would encourage large-scale utilization of red mud, which in turn echoes the prevention of growing adversities associated with the disposal practices and consumption of valuable natural resources. So here, it is very important to understand the entire concept of red mud application when in all the ways, like both sustainable, safety, when you are using also how it is safe and how it is workable. All those things, if you study, definitely in a large scale utilization is possible. Very few works of literature available on the interaction between the red mud and other industry-based metals and additives. Literature on the environmental aspects of the stabilization with more additives has not been given much attention. So this shows that the current work, such as the suitability of stabilized red mud for subgrade material with supporting microstructural analysis and geoenvironmental study, be a new platform needs immediate attention. So here I'll be explaining you how I did work on utilization of this red mud along with other industry waste materials, because the topic I have chosen is application of industry waste materials in the road construction. So I'll explain you what are different types of industry waste materials I used and how, because sometimes only industry waste material, one industry waste material and another industry waste material together will not work. Definitely you need to add some additives, maybe like chemical additives or solid additives. So I'll explain you in detail. So objectives are to study the index and engineering properties of raw red mud, like particle size distribution, specific gravity, liquid limit, rational limit, OMC, microstructure analysis. To study the strength properties and microstructure analysis of all the waste materials used in the study, and to estimate the suitability of red mud as a subgrade material with other industry waste materials, and to investigate hazardous limits of the leachate. And the last is when we speak about, and the last objective is very important, because when we speak about utilization or application of industry waste, the first question comes on us is how safe? How safe it is. So for that reason, we did a leachate study, that is collection of leachate and doing the chemical analysis of the leachate. Leachate is nothing but the way once the water percolates into the soil or through the waste material, the water which percolates and finally collects at the bottom, that is called the leachate. Okay, so this leachate we collected from the red mud and the best combination of red mud and other industry waste material, and we connected chemical analysis and we compared with the safety limits of WHO and TCLP hazardous inputs. So here materials, the first one is the red mud. A solid red mud was collected from the Hindalco Aluminum Industry, Belgaum, Karnataka, India. The collected red mud was allowed to air dry to use for the testing. Red mud mostly contains silt, that is 75% it is silt, which passes through 75 microns seed, and the remaining fractions are clay and sand of 15% and 10% respectively. The silt is predominantly more in red mud and is classified as a silt of low plasticity as per the Unified Soil Classification System. So, according to the USCS classification system, it is considered as ML, it is low plasticity silt. Okay. And the specific gravity of red mud is measured as 2.85. The compaction test of red mud were determined by performing modified Proctor compaction test, and the optimum moisture content, the OMC is 31.39% and the MDD is 1.57 grams per cc. So this is the brief story of red mud. And when it comes to other industry materials which I used in this research study are fly ash. The fly ash was obtained from Raichur Thermal Power Plant at Shaktinagar, Raichur District, Karnataka. It is a coal-fired electric power station operated by the Karnataka Corporation Limited and generates 1.5 million tons of fly ash annually. That's I took from the literature. And another industry waste material is ground granulated blast slag, GGBS, which is nowadays extensively used in making various types of high-performance concretes. So even I used that GGBS. GGBS was procured from the JSW cement factory, Tornagalu, Karnataka. GGBS is produced as a byproduct or waste from the blast furnaces during the process of making iron. Here, intentionally, I mentioned from where I have collected this material because definitely it may help the PhD scholars or any faculty if they are interested to work on these materials from where they can collect. May not be exactly from the same location, but at least they can understand from which unit or from which factory they'll get these materials. Because when I started working, to be frankly saying, I'm not aware that exactly from where I get this IoT, where I get foundation, because many research articles they'll mention that foundation, IoT and all, but very few they'll highlight from where they have collected. Maybe sometimes the material is easily available even next to my door, but I don't know. I don't know that exactly that material can be used. So that's the reason I have mentioned here very clearly from where I have collected. IoT was acquired from BMM ISPAT mines located in Ballari, Karnataka, India, and we did XRF was used to perform the elemental analysis, and X-ray diffraction was used for mineralogical composition. We did extensively XRF, XRD for all the materials. Next, foundry sand, the other industry waste material foundry sand used in this research work, which is also a waste material produced from the foundry cluster, and this was collected from Bangalore itself, from the foundry. So here, if you observe, you can clearly observe the SEM image of Redbird. The figure A shows SEM image, and figure B shows the XID of Redbird, and figure C shows SEM of FK, that's a fly ash, and figure D shows XID of flash. So here, if you observe, the exact SEM images of Redbird and fly ash are completely different. So here, if you clearly observe, that Redmond has a different shape. Image has a different shape of particle, and when it comes to flash, has a spherical shape. So the needle shape and the spherical shape are the best combination to increase the strength. That's what the research says, and even we tried the same level by mixing these two materials. And same and XID of GGBS, IoT, and FS are mentioned here. You can clearly observe GGBS, SEM XRD, IoT, SEM XRD, then foundry and SEM XRD. Next, when it comes to chemical composition of various industry waste materials by performing XRF analysis. So, if you want to understand the chemical composition of any industry waste material or any material, then you have to perform the XRF analysis. And we perform XRF analysis on all the 5 industry waste materials which we used in this research study. Foundry sand, GGBS, red mud, IoD, fly ash, and here you can observe silica, the concentration of silica, the concentration of aluminum, ferric oxide, calcium oxide, magnesium oxide, sodium oxide, and tetroids, paved. So, along with these industry waste materials, as I mentioned, just using industry waste materials may not help. Definitely, we need to add some admixtures. So here I have chosen gypsum, lime, cement, NaOH, and Na2SiO3. These are the admixtures which I used. Today, in this session, I'll focus more on the application of geopolymer or NaOH and Na2SiO3, and I'll show you how the chemical properties, all those things will change. So here, the methodology is material collection, finding the geotechnical properties, finding the chemical properties, determining the microstructural analysis, that is SAM XRD. Next, different combinations what we use, that is red mud plus fly ash, 90% red mud, 10% fly ash, 80% red mud, 20% fly ash, 70% red mud, 30% fly ash, and the same set we used for GGBS red mud foundation, red mud IoT. Okay, and for these materials, we mix the admixtures cement, lime, gypsum, and sodium hydroxide and sodium silicate in 1, 3, and 5%. So for this combination, for example, if we take 90% red mud, 10% fly ash with cement, lime, gypsum. Cement again 1%, 3%, 5%. Lime 1%, 3%, 5%. Gypsum 1%, 3%, 5%. Like that, extensive study we did, and we limited the application of admixtures only to up to 5% because it is known fact. If you use more admixtures, definitely your strength will increase, but at the same time, the cost of the product will increase. So we don't want the more cost, and we tried only very limited minimum application of these admixtures. And when it comes to results and discussion, detailed geotechnical properties of various industry waste materials. Here you can observe, we determine the various geotechnical properties to understand the complete behavior of the various industry waste materials. Definitely, if anyone wants, you can take the pick of this. Definitely, this helps you as a base for many of your proposed research works, because this is my research work for almost, I think, 5 years. I worked extensively on all these materials and came to this conclusion after comparing with a lot of literature. So here, the specific gravity, pH, liquid limit, cluster limit, and the classification of soil, the classification of the waste according to the soil classifications, and compaction test. From the compaction test, we determined OMC and MTD, that is optimum moisture content maximum dry density. CBR, when we talk about the roads, definitely the most important thing is that CBR, California bearing ratio. Here, the CBR for unsoaked and soaked, though unsoaked is not that great, but to understand how much of water absorption, water logging capacity is there, we did both unsoaked and soaked. Though soaked values are important when it comes to the road construction, particularly in the subgrade and subbase materials. And here also, we also determine the usages of all these materials. The major material in this research is red mud, and the major parameter is CBR and usage. If you observe the CBR of red mud is 1.87%. And definitely to use red mud or any other material in subgrade, the IRC specifies minimum 8% should be the CBR, minimum 8%. But here, if you observe the red mud, the CBR value of soaked red mud, unsoaked is okay, pretty good, reasonably fine. But when it comes to a soaked CBR value, which is a 4 days soaked CBR value, it is 1.87, which is highly not acceptable for the construction of any roads. So study on red mud with fly ash and admixtures. So here, the first study is red mud with fly ash and admixtures. That is the first admixture is gypsum, and the best combination among all these things is based on the CBR. Let us look at only on CBR and UCS. The best combination among all these trials is the CBR of 10.44% with 95% red mud RF2 plus 5% gypsum. So what is RF2 is 80% red mud plus 20% fly ash. 80% red mud, 20% of fly ash we have taken. How I'll explain you one set how we came to this combination is first I have taken 80% red mud. That means 8 kgs of red mud, and I mixed with 2 kgs of fly ash. First I made this as a one material. That is RF2. Okay, so for this RF2, I have taken 95% of RF2, okay, and 5% of gypsum. For example, if I'm taking 1 kg, okay, in that 950 grams of RF2 mix and 50 grams of gypsum. This is the way how I proceeded with my research. Okay, because there may be always a doubt, because when I was guiding my PhD scholars, they'll come to me and they ask me, sir, how to mix these materials? What is this combination? What is this number? Whenever I share my articles, there will be a question, sir, what is this RF2? What is this 95% RF2? This leads confusion to us, because when I want to present the total 1 year work in one paper, definitely I have to use all shortcuts. But in detail, that's the way how we proceed, and that's the best method what I identified from the research. And strength properties of red mud with fly ash and lime. Here, the another admixture with red mud and fly ash is the lime. So here, the best combination we found same again. Here also 80%. See, overall 80% red mud and 20% fly ash has given the best results. And with different types, different percentages of admixtures. Here also 5% lime used has given the best value. That is 8.12% of CBR and 1,890 kPa of UCS. Next, strength properties of red mud with fly ash and cement. So another important admixture which is a popular admixture is cement. With cement, we attained 11.11% of CBR and 2,340 kPa of UCS. And the geotechnical properties of red mud, fly ash, NaOH and Na2O3. So generally, this combination we call it as geopolymer, right? Nowadays, a very popular term or very popular work is geopolymer. So we tried on geopolymer also, and this is the combination and the maximum. This is the OMC and MDT, because when you're using the geopolymer, that is a NaOH and Na2SiO3, finding the optimum liquid alkaline content and the required MDT is a challenge. That's why I projected this also, because it's not just water. We need to mix these solutions in a proper way, and that solution has to be presented as a OMC for this combinations. And the CBR values of red mud fly ash blend and red mud fly ash geopolymer combinations. So here, red mud fly ash and red mud fly ash with geopolymer. So RFG9, which has 70% red mud plus 30% fly ash with 100% NaOH, has shown the highest CBR. That is approximately 12.1% of percentage of CBR. And when it comes to UCS of red mud samples with water and with alkaline solution, here is the UCS. And we conducted the unconfined compressive strength for 1 day, 7 days, and 20 days. So here is the clear data, and you can observe the bar shows that 28 strength is high, okay, which indicates that this red mud has a capacity to increase the strength with the time with exact addition of admixture or the flour or the another base material. So it shows that increase in the strength is the best indicator with the time to use as a construction material. And SEM extra images of RFB2 there is with water 80% red mud and 20% fly ash with water, and RFG6 there is 90% sodium hydroxide, 10% sodium silicate, RFG8. These are the three combinations which showed the best results. So we just took those three combinations for this study: RFB2, RFG6, RFG9. The same image of 10% replacement of Na2SiO3 shows the needle-like structure, which is not observed in red mud fly ash water blends. You can observe here needle-like structures in the SEM image of 10% replacement indicates appreciable reaction of alkaline material, and it also indicates that CaH and CSH formation was observed. The peak at 35 and 55 degrees on the exact image of RFG6 combination, this is the RFG6 combination, shows the presence of alkaline and hematite and aluminum, which indicates the good strength. So whatever the research we do, if you just show CBR, UCS, or any strength value, nowadays nobody accepts it. Definitely, justification is required, and justification only comes by doing the microstructure analysis. And that's the reason we did microstructure analysis on the worst sample and the best sample to understand how the equation works. And here we also did FTIR, Fourier transformer Fourier transformer infrared rays test FTIR. FTIR basically gives the bands. So these bands you need to identify, and the band stretch indicates how much of water is present and how the strength is changing from one place to the other place. And in RFG6, new bands had observed at 1643.20. And another band is at 3038.33 per centimeter, suggests the chemical reaction that results to geopolymerization. So these bands, okay, at these two values indicates that the geopolymerization has happened. This conclusion came by looking at various research papers and research by discussing with a lot of physics and chemistry people in our school. We discussed a lot of them and how to draw, because this is completely new. FTIR is completely new, and I think civil engineers very rarely work on FTIR. So when we did on FTIR, definitely we took their help, and from the literature, from the research, we understood that geopolymerization happens when you have the band stretch at this scales. And this is the RFG8 combination. Next, study on red mud with GGBS and admixtures. So that till now we discussed about red mud fly ash with admixtures, and let us now look at red mud, GGBS and admixtures. Start with gypsum. So here CBR is 11.88% for 95% RG2 plus 5% gypsum, and UCS compared to the fly ash, UCS was increased with GGBS. Even the CBR also increased with GGBS and the gypsum compared to fly ash. Okay. Next, strength properties of red mud with GGBS and lime. The another admixture we used here is the lime. OMC was reduced and maximum MDD was attained with 90% of 70% red mud and 30% GGBS with 5% lime, and the highest CBR value was recorded 8.7 So among all the admixtures, what we understood is lime has less strength. Of course, we all know cement has the highest strength and lime has less strength, and even NLCS also indicates the same way, same trend. But what I'm going to highlight here is even with lime, we attain 8.78, because if anything is more than 8% of CBR, it is highly appreciated and highly acceptable for the use as a subgrade material in the road construction. So generally there will be a question many times when I present my research in forums, different forums, there will be a question. Generally subgrade material is the existing soil. Generally, existing soil is taken, the soil bed is taken as a subgrade material. So where we can use this red mud and the research. See, some places we don't accept directly the existing soil. Definitely you need to remove the soil and bring the other soil which has capacity. Because sometimes we encounter the weak soil. When you go on field, we encounter the weak soil. Definitely, you cannot attain the CBR of required CBR for that soil. So in such places, they'll remove the soil and they'll add the soil which has enough strength. Generally, they'll use boron soil in such replacing. In such replacing situations, definitely this red mud will help to use extensively. And when it comes to road applications, unlike any other application, road application will require huge quantity of waste, huge quantity of material. Okay, cut and fill. We all studied the cut and fill of method for the construction of roads, subgrade or subbases. So I focus more on subgrade, where if the CBR is more than 8%, definitely that can be used as a material for the subgrades. And strength properties with GGBS and cement, you can observe here the cement. Sorry. Yeah. With cement, the CBR achieved is 12.89% and was attained with 5% cement and 95% of 20% red mud, 20% GGPS. So overall, if you observe among the 1%, 3%, and 5%, now all the combinations, 5% shows the best value. But I also projected, I want to also highlight even 3% and 1% also satisfy the need of 8% CBM and even the UCS of 2000, more than 2000 kPa. So if you can just by using 1% or 3% of cement, okay, if you can get the strength, for example, here 3% cement, 19% RG2 with 1% cement, you achieved 8.43 CBR, which is excellent. Okay, so even that also will work. Okay. Next, the strength properties of red mud, GGBS, and alkaline solutions. So again, here we used sodium hydroxide and sodium silicate in different percentages. Here I presented you the CBR, and the highest CBR with this combination is 13.56, and the UCS value we achieved is 1980. The combinations used for testing structural analysis or microstructural analysis is RG2, RGG86, RGG7, RGG8. So these are the samples which we do. What is RG? RGG2 is 90% red mud with 10% GGPS, which doesn't have any admixture. Next one, RGG6 is 90% sodium, 80% red mud plus 20% GGPS, which is considered as 100%. With, instead of water, I use 90% sodium hydroxide and 10% sodium silicate. And next one is RGG9 and RGG8. RGG7 is 60% sodium hydroxide, 40% sodium silicate. Next, RGG8 is 50% sodium hydroxide and 50% sodium silicate. So why we did study here is instead of using just one material, if you apply sodium hydroxide and sodium silicate in different concentrations, how it works, that's what we studied here. And among all this, 90% sodium hydroxide and 10% sodium silicate has given the best result of CBR and both UCS, that is RGG6. Nowadays, people started working on completely one material instead of mixing two. So nowadays people are started moving on only using sodium hydroxide or only using sodium silicate, and they are calling it as one part alkaline material. If anyone is interested, even you can work extensively on this one part alkaline material, that is using just sodium hydroxide or only sodium silicate instead of water. Mixing with water is fine. Only water instead of water. If you use these materials, they are called as one part alkaline material. If anyone is interested, focus on that. And here you can see these combinations of SCM and XRD images. And next material is strength properties of red mud with foundry sand. So this is another waste material with gypsum. So here the maximum CBR we attained is 8% with 95% RFS2 plus 5% gypsum. Of course, gypsum doesn't have much impact on the strength, and it shows the cracks basically. And the strength properties of red mud with foundry sand and the lime imparts the strength with the curing period, but the presence of foundry sand will not help much to use this material, or combination is the best to use in subgrade. CBR value also will not attain the minimum CBR of 8% use as a subgrade material, but it can be recommended in low volume road construction to make an environmental sustainability perspective. So though here we don't achieve the 8% CBR, but this combination can be used. For example, if in your locality where the red mud is very highly available, in such places they can construct the low volume traffic roads. See, what do you mean by low volume traffic roads? You can search the codal provisions or the IRC provisions. What do you mean by low volume? What does it mean by high, medium, high, okay, regular, there are different standards, okay. So based on that, you can understand what is mean by low volume and that is based on the traffic, okay. So in such roads, you can use even though it is less than 8% up to some extent. Next one is red mud with foundry sand and cement. In this combination, also cement plays as a best admixture to improve the strength of red mud and foundry sand. UCS strength was improved from 712 kPa to 1890 kPa with addition of 5% of cement, indicating the good pozzolanic property. CBR value also observed to be increasing with the addition of cement compared to the bare combination, and the highest CBR value of 8.99% was achieved with the 5% of cement, and the soaking shows the improvement in CBR value, which again supports the reaction due to the presence of cement and water. Again, iron ore tiling, the another combination is iron ore tiling. So here next industry waste material is red mud with iron ore tailing, and additive is gypsum. So MDD, the maximum dry density, increases because of IoT becomes the major material with a larger particle size, and the red mud becomes filler in that. So when we use red mud and IoT has a very high density because it's an iron ore tilings. So because of that high density, you get the maximum dry density. Okay, once you mix IoT with red mud, you can easily attain the very good density for the combination, and but the MDD will not be influenced upon the addition of 30% and more of IoT to red mud because it shows the reaction to the load or the iron ore tailings takes the load rather than red mud and shows the reduction of the dry density. So we read it up to 30% because after 30% we didn't find anything, any strength improvement or any density improvement. So that's why we restricted up to 30%. UCS was increased with the addition of IoT to red mud, but it is a minimum as there are no cementitious materials are available in IoT, and suitable increase was found under 20% replacement. Strength properties of red mud with iron ore tailings and lime. Here, 20% of iron ore tailing with lime shows a marginal increase, not that great, but still, as I mentioned earlier, it can be used for a low volume roads. Okay, though we don't reach 8% because some places even they say that 2% of CBR is accepted, but for a very low or rural roads construction. The cement hydration, I mean, strength properties of red mud with iron ore tailings and cement. Cement hydration produces cementitious material. There is a calcium silicate hydrate, CSH, and calcium aluminum hydrate, CH crystals, which bind particles together and increase the compressive strength. Even with 3% of cement addition also shows the required CBR and minimum UCS. So here, even though red mud and iron ore tiling, though the density is good initially, but when it comes to the CBR, which is a very important property for the construction of roads and road upgrades, so it is not matching much. But with the addition of admixture like cement, it helps to increase the strength, and you can attain the CBR more than 8%. Even UCS is nearly to the 2000 kPa at 28 days. Now, the very important parameter, geo-environmental perspectives or geo-environmental concern, or study of this development with other industries, materials, and the natures. So, when you say geo-environmental, it is important to collect the leachate. And here, I followed a method called TCLP, toxicity characteristic leaching procedure. This is the TCLP procedure, which is a very important and dominant procedure in abroad, where they use this procedure to collect the leachate and they study the chemical analysis of this. So same procedure I follow. Actually, initially we tried to collect the leachate by using a permeability set of apparatus, but because of the fine particle size, we don't collect the leachate even after a week time. We just got 1 or 2 drops of leachate. So we decided the regular procedure to collect the leachate will not work because generally we collect the leachate if it's a sand or any other municipal waste, we just keep on a permeability setup. We can collect the leachate, but when it comes to a very fine material, leachate with the regular permeability setup will not work. So we referred the research articles and we found DCLP is the easiest method, and we followed the DCLP method. where we mix with the distilled water, pH, we maintain the pH, and it's a different story. If you are interested, you can search my papers for the TCLP, how we perform the TCLP method, because in one of my articles, I explained in detail how we can perform the TCLP, and also explain the alternate methods, because sometimes we may not get exactly the 2 micron filter paper, or sometimes even they mention that less than 1 micron filter paper. Sometimes we don't find in such cases how this alternate method also I explained, and I found some ways to collect the leachate in the during the genomic study. So once I collect the leachate, here we collected the leachate for red mud RFG6. That is 80% red mud with 20% ash, with 90% sodium hydroxide and 10% sodium sulfate. We restricted our work of leachate collection to the best sample, because it takes a lot of time and lots of money involved. So we restricted to the best combination. For the bare combination and the best combination, we studied to understand how the equations are working. So here the results obtained are red mud and RFG6 are like arsenic. And here also there's one more very important thing which you need to understand. If you want to find all the analytes in the collected leachate, I think one sample they charge around 15,000 in Bangalore. Okay, so for one sample, 15,000, and if you want to test some 10 samples also, it is like 1,50,000. I think it's too high. Okay, so my guide suggested don't go for all the samples. I mean all the analytes. Choose the analytes which you want to understand. Okay, so based on the previous research study, and based on the chemical composition of this red mud and fly ash and other materials, I came to a conclusion that I'll be studying all these 8 chemicals and the concentration of 8 these chemicals, because these are important. At the same time, these are hazardous, and these will be present in my material based on the my chemical composition. So I decided arsenic, cadmium, chromium, lead, mercury, sodium, calcium, and silica. These are the chemicals which I want to check what is the concentration of these chemicals in the collected leachate. So for the red mud, if you observe, it is 0.001 arsenic milligrams per liter, and RFG6 combination has 0.159. And here I compared with 3 standards. One is primary drinking water standard, TCLP hazardous waste limit, and WHO standards of drinking water. So here for arsenic, the drinking water is it should be less than 0.01. So the red mud and RFG6, the concentration of arsenic is within the limits. And when it comes to cadmium, I more than drinking water or WHO standards, I'll focus on TCLP hazardous waste limits, because that's the procedure which we follow, and better to focus on that. So here almost all falls under the consideration except silica. Though silica, everything falls under the consideration under the limits of TCLP. Though WHO standards, if you are not matching with the WHO standards of drinking water, but TCLP hazardous waste limits, 100% it is safe. Okay, so this research and this study helps to understand in detail that how safe these to use this red mud with other industry-based materials and other chemicals or other admixtures. So here, if you observe, even it satisfies almost all the primary drinking water standards, maybe except one parameter, that is the calcium. Though the calcium is 216 and 255, the limit is 20 to 208. Though calcium is more, just 1 or 2 parameters will not match, but the rest all will fall pretty good in the standards. So that strongly recommends and says that yes, this can be used for the construction subject. And here some comparisons I made with various combinations. Basically, I focused on CBR and UCS. CBR and UCS of 28 days and CBR of 4 days for red mud fly ash combinations are projected here. And blue line indicates red mud, fly ash, and gypsum. Red and brown line indicates red mud fly ash with a lime. Green line indicates red mud fly ash and cement. Now, almost all the combinations of the cement has better strength. Only with 99 RF2, gypsum has better strength, because some places even gypsum has shown the better results compared to the lime. And here, the combination of CBR and UCS for red mud GGBS combinations, red mud foundry sand combinations, red mud IoT combinations, both CBR and UCS. So now let's move to the conclusions. So conclusions based on the characteristics of red mud waste. Specific gravity of red mud shows that red mud is suitable for use as a subgrade material, similar to any material used in the subgrade construction of the roads. For natural soil, generally subgrade, specific gravity falls between 2.65 to 2.75, though we have 2.8. It is acceptable. The sieve analysis shows that 10% of sand, 75% silt, and 15% of clay size fractions in the red mud sample, concluding that red mud has similar properties of silt as the major proportion of silt is present. The study on SEM images showed that the quantity of angular shaped particles in red mud varies from 71.65 to 91.23%. A larger fraction of angular particles seems favorable as it can contribute to considerably frictional resistance with simultaneous providence of counteracting to the upgrades. If anyone is interested, you can search papers. There are some papers which focus only on SEM image of red mud and how the angular shape particles will help to increase the strength. Definitely, compared to the round shape, angular shape has a better resistance and better friction. So that is one add-on property for this rail. The high content of iron and aluminum in red mud was reported to be beneficial for utilizing it as a raw material in cement production. Optimum moisture content was obtained 31.39% and maximum dye density was 1.57 grams per cc. And which also supports to use this material as a subgrade material with the comparison of OMC and MDD of any regular subgrade soil. Even any regular subgrade soil has a similar type of OMC and MDD. The UCS of red mud is in the range of 520 kPa and 612 kPa. The reported values are less compared to the clay of low plasticity. So if you look at any clay of low plasticity, the values will be much higher than the red mud. Thus, it indicates that suitable stabilization is required to use as a geometry application. CBR of red mud after soaking for 4 days was found to be 1.58%, which is very less to use as a subgrade material where minimum value required for low volume roads is also 2%. So next, the conclusions based on the red mud with fly ash and admixtures. So with fly ash and admixtures, definitely it has shown very good strength both with UCS and CBR, and also it supports the microstructure analysis also supports it as a best combination. And the FTR images of geopolymer combinations indicate the formation of new reaction products that is a calcium silicate hydrate and calcium aluminum hydrate. So FTR also supports the strength improvement. Conclusions based on the strength properties of red mud with GGBS and admixtures. So here, GGBS also has supported, along with the admixtures, help to increase the strength of red mud, and the CBR of 13.6% and the usage of 3,267 kPa were obtained with the alkaline activated 20% GGBS stabilized red mud. So among all the combinations, we achieved the best CBR and UCS with alkaline activators, that is sodium hydroxide and sodium silicate. So if you apply red mud directly with sodium hydroxide sodium silicate, it will not work much. But when you mix with the GGBS or the fly ash, definitely it gives better values and a better strength. And 13.6% is absolutely fine. When I projected this in one of my, one of the international conference also, they appreciated that achieving more than 10% CBR is very good to use in the road construction, where industries can accept. The SEM and XRD images show the presence of show the process of alkaline activation in GGBS and red mud. A dense matrix due to alkaline activation of the 20% GGBS mix can be observed, which indicates the proper gel formation. And the presence of the amorphous phase leads to the development of hypogelonic activity in GGBS. The XRD pattern of red mud and alkaline activated red mud GGBS mix cured for 78 days at ambient temperature shows the strength improvement with the peak of various parameters. And here, as I told you, I'll give you a lot of scope for your work if anyone is interested. One more very important parameter is increasing the temperature. Okay, here hybrid alkaline activated with red mud and GGBS or red mud with fly ash create temperature of 110 degrees centigrade. Okay, so if anyone is interested, you can work with the increase of temperature. Definitely, the geopolymerization works very good with the increase of temperature. So we can check the geopolymerization and how the strength is improving with the various temperatures. Like when you go for 200, 300, 400, 500, 600, and if your lab supports even 1000 degrees centigrade also, you can perform the test. Yes, okay. So this is one area where you can, if anyone is interested, you can work like increase temperature variations on the strength improvement of alkaline activated red mud and other materials. Not only red mud, can any industry waste material with geopolymer strength. Geopolymer strength depends on the temperature. The conclusion based on the strength properties of red mud with foundry standard admixtures. I look at basically the severe value was increased with the addition of fondant to red mud with up to 2.87% with the addition of 20% fondant. The severe value is reduced at the 30%. Addition as sudden cracks were developed. Yes, actually, when we used 30% of fondant sand, when we were doing the CVR test, sudden cracks we observed in the both in CVR and UCS. So it indicates that because the crystalline structure of the foundry sand will not help much to increase the strength and will not coordinate with the red mud. And yeah, so the addition of 5% to the 20% foundry sand stabilized red mud showed appreciable values in this waste material combination. Next, with the iron ore tilings and the admixtures with the red mud. So 5% cement and 20% IOD, the UCS value attained was 1937 kPa, which is good to use as a subgrade material according to the ISO specification for low to medium traffic roads. And cement and gypsum reacts well compared to the lime with the IOD. The red mud and cause stabilization on soaking in water for 4 days with the subgrade. Subcharge. Okay. The severe values of red mud IoT with 5% gypsum and 5% shows severe 7.15 and 8.45% respectively. And it indicates almost 4 times to the actual red mud severe value, which again proves that application of, yeah, I'll explain. It indicates almost 4 times to the actual red mud severe value, which again proves the application of red mud with IoT as a sublimit. On the other hand, the density of IoT helps red mud to be stable with the application of the subgrade of road construction where it is covered with the top layer. So even if, as I told you, iron ore tailings has a self density. So some places even we did a study where only iron ore tailings in red mud increasing different parameters. Okay. Some increasing 100 to 0, 0 to 100 different parameters we tried. Just directly by using of iron ore tailings on red mud will work to use as a road construction material. This is also one area which a lot of people are not extensively working. Of course, because I don't when we say iron ore tailings, it's a hazardous material and people rejects, but a lot of research, a lot of scope there. Conclusions on the chemical analysis of leachate of various red mud and industrial combinations. The addition of admixtures to all the combination of red mud with fly ash, GGBS, foundry sand, and IoT helps to reduce the concentration of heavy metals because of the fact that the cementitious products create a solidification which results in the limiting of hazardous elements when it comes to in contact with the water. So the beauty of this combinations is when you add cement or any cementitious products to the waste, this creates a solidification, and this solidification will not allow much water to pass through the soil. Okay, even if it passes through the soil or through the waste material, and the concentration of the hazardous materials will be limited. Okay, most of the hazardous waste materials will be restricted by these cementitious process. Okay, among all these admixtures, cement stabilization reduce the impact of heavy metals in leachate, and IoT shows the increase in the concentration of secondary heavy metals, which again needs to be studied in a better way. So that's what I said. IoT, though the concentration of primary heavy metals was reduced, but the secondary heavy metals, which are called as other hazardous materials, has increased. Okay, so that needs to be addressed because sometimes even though one concentration is less, other concentration increases. So as I told in the earlier, I have chosen only 8 chemicals or 8 analytes because of various parameters. So the DCLP analysis on geopolymer materials and alkaline activated red mud shows that the leaching of toxic metals is within the permissible limits and shows the composite safe with the GM. The overall conclusions, if we look at red mud with 20% of fly ash and GGBS increase the strength up to 2 times, it can be used as subgrade material. Cement and chemical admixtures shows the best results and improves strength up to 4 times and highly recommended for substrate application. Red mud with 20% of foundation sand or IoT improves the strength but not efficient and details, only satisfies the requirements of substrate with additional admixtures of fibers. Geo-environmental study satisfies the red mud formulations as safe material to use. And the scope for the future work here, though the entire process I gave a lot of hints and a lot of gaps. Here are a few points I would like to highlight. To understand the economic benefits of this material, a detailed economic input output cycle assessment, that's called EIO LCA, is required and can be considered as future work. So if anyone is interested, as I was discussing with Chaitanya sir, he told me just give some inputs also where you found there's a gap. So that's where I thought I mentioned the scope. So economic benefits, particularly how the idea which I proposed, that is usage of red mud with other industrial materials, is economical. Definitely, it is economical at the places where abundant amount of the red mud is generated or any waste material is generated. So if you nowadays, if you are proposing any material, definitely they'll ask you how it is beneficial, what is the cost analysis, what is the product cost, how it is economically good. First, two things. One is safety. Of course, safety and quality as one parameter. Uh, another parameter is how these another parameter is how what is the cost. Okay, how it will reduce the cost and how it will help. Definitely, if we researchers are able to address the cost issue, okay, and at least a few companies will come forward and use these material. At least if one company uses this material, yes, our research is success. Because all this research should not go waste and it should not limit to just maybe some conference or FTP. Me and my team essentially works where we can practically apply. Even we are trying to construct a road by using of these waste materials and this study that in our campus, because we don't want directly to go outside, because outside to construct the road definitely we need a lot of permissions and approvals from the government bodies and other agencies. So we decided let us construct a road by using of these waste materials at least a minimum stretch, maybe 100 meter stretch, and let us look at least 1 year cycle, how it works for various temperature conditions, various climatic conditions, because the real-time application or real knowledge only gets when we apply it in the real world, not in the laboratory. Definitely, laboratory values, I think many of you will acknowledge my word, like laboratory studies shows one parameter when you go apply, and real time shows different parameters. Okay, so the values and the equations, everything will change when you go and apply in a regular real time. So we cannot completely go on the laboratory. So we are trying to start working at least a stretch of 100 meters road by using of this entire study. And more detailed studies on red mud with other amendments are required to use as a liner material for landfills and so even you can study. Although I focused here red mud with only subgrade, you can study on sub-base applications. You can study on landfills, embankments, okay, and many other areas. Nowadays, we are seeing a lot of landslides. Okay, why not a landslide? Uttarakhand landslides. A lot of landslides. There are a lot of landslides. So, how this material can help to increase the stability of these areas? Okay, so in that way also we can think it's a different area, just proposing. As the material poses still characteristics, the influence of compaction energy on improving the density with various additives can be studied in depth. Application of red mud with one part alkaline activator, which can be used user-friendly. Stabilization method can also be considered for future work and application as a backfill material, where an enormous amount of material will be used. So another important area is a backfill material. I hope you know what is a backfill material. So where a huge amount of material is used, uh, where huge amount of material bring from different locations and they'll dump it as backfill. So in such places, you can use this red mud, but definitely you need an extensive study when you're saying backfill. What are the parameters to observe? You have to observe them and study extensively on that. I'll answer everything. The other questions is popped up. I'll answer one by one. Next, durability of these formulations can be studied further to apply them effectively for a long-term, long-lasting performance of substrate. So this is also one area because after doing all the works when we discussed with our other people and my mentors, there's a question like what is the durability? How you check the durability? So if anyone interested, you can even focus on the durability of these formulations. So I have not touched any durability. I have not touched any durability of these formulations. If anyone is interested, you can refer my papers. You can start working on durability tests on these combinations directly, and that will become a very good research. Okay, and that's what my guide, who is my mentor guide, and I feel like a godfather, Professor Krishna in JNTU Anantapur, who is an expert in geotech. He suggested me only question comes from research and answer comes from research. That's what he says. So he suggests me to read a lot of articles. So that's where I learned, understood a lot of concepts, understood many things. So digging one after the other paper, if I don't find the answer in that, I go to another paper, another paper. Finally, I have to find my own solution. Okay, so definitely some places, some research ideas just comes very easy way. Among them, this is one idea. Okay, so when you have ready-made work, you can take my work or any work and just study on durability. Then it becomes a very good research, maybe at MTech level. And if you study extensively, you can even work. You can propose this work as a PhD. And these are the references, and here are a list of publications. Though I think beginning they mentioned 20 research articles I have, and I just mentioned here only 6 which are published on this topic. I have research articles on various materials like concrete, all those things, and these are the research articles which are published on this study, and these are the conference publications. So this that's all. And my first image started with the green roads. That means where we can propose the roads, construction of roads based on waste method. And slide shows that waste to an asset, where waste can be converted into asset. This is the way how we start separate and some base goes further with that. So that's all from my any questions. I go back to questions here. I can see the questions. Yes. So, yeah, there are some questions. Yeah. First question is please explain on how the sampling is done for leaching test and stabilized soil. Yeah. So this is called TCLP test. Okay. Toxicity characteristic leaching procedure test. For TCLP test, what you have to take is you have to take some 30 grams of sample. What are the sample? Okay, which is passing through the 425 micron seal. You have to take some 30 grams of sample and you need to mix this 30 grams in 1:20 ratio with the distilled water which has a pH value of 2.65. You need to bring the distilled water pH to 2.65 and you need to titrate this solution uh, with the powder. You need to keep in a beaker and you need to rotate this solution along with the water for 18 hours. Okay, at 2 rpm, 2 rotations per minute, or 2 rpm, 18 hours we should continuously rotate. After that, this transfer into a container by using a filter paper of 2 microns or 1 micron, not exactly, 2 microns filter paper. By using a 2 microns filter paper, transfer and filter the solution. What you get is the leachate. Okay, and detailed procedure, which solution, what pH, and how to use everything I mentioned in my research article. You can search my research article, Sharchandra detailed geotechnical study on red. There I explained you leachate procedure and TCLP procedure. Okay, there you can understand. Next question is stabilized soil will be almost impermeable in the collection of leachate sample from stabilized soil for the test is to explain. Yeah. That's what I'm saying. Though we say stabilized soil, okay, impermeable. That impermeable with soil cannot be possible. Definitely there will be a permeable. Okay, even concrete roads. Yes, cement roads. We call cement roads, right? Even cement roads, we observe there's a permeability. Even though we say impermeable, there's a permeability, and so definitely stabilized soil will have chances of having a permeability. And very important thing here I would like to mention is it doesn't mean that always water has to percolate in this direction. It doesn't mean that. Okay. Water can come in contact in the horizontal direction. This horizontal direction, maybe at the ground level, also contact and pass through different layers of soil and may pollute the existing groundwater. It doesn't mean that always it has to go in the horizontal direction. In geotechnical, we also studies the lateral force of water and uplift of water and permeability concept. So definitely it can be. So we cannot say impermeable. May I know what kind of tests to do for Redmar and what could be the size of particle to use in mix? I'm not sure about this mix design concept or concrete mix. I think you may be asking about the concrete mix or something. I'm not sure with respect to concrete, but with respect to geodetic, generally this is a fine grained particle. Okay, it has 70%, 75% silt. Even as I told you in my MTech at NIT Bhopal, I studied Redmar from which is collected from the Chhattisgarh. Okay, that's a red mud from the rainy coast, Chhattisgarh. That material has 80 to 85% of silt. Okay, so silt content varies. It has more silt. So generally, we call it as a silt kind of material. Though it is not exactly silt kind of material, I can say. Anything? Any core samples collection and testing done? If she said. I'm sorry, Surendra Patil. What do you mean by any core samples collection testing information? What is meant by core samples collection? Can you tell me? I don't understand what is meant by core sample. You mean core sample means the raw sample? Yeah, that's what I'm saying. The red mud which we collected, we just bought it and kept for air drying. Kept for air drying, and after air drying it for almost a week, we didn't keep it in oven. We just air dried it and started working. So the initial test, what we did is all in core samples, and the final test after stabilizing with various mix, that's it's considered as a finishing slide, finishing products. So definitely, there's a lot of improvement both in CBR and UCS. Even the density, dye density also increased extensively. Okay. I hope I addressed your question. Uh, Thank you, Mansurati, for raising a good question about the size. Though I don't have much idea on the concrete mix. Yes, it has a cell size. Sriram, thank you. And, yes, yes, that's all. Any other questions? Someone raise their hand. And Ashwini, or any question? You can put it in the chat box. Any question? Shishu, the yeah, yeah, definitely. And explain, please explain geopolymer once again. Thank you. So geopolymer, what it is? When you say geopolymer, okay, we generally use sodium hydroxide, sodium silicate. Okay, so we took sodium hydroxide and sodium silicate. Sodium hydroxide comes in the pellet form. Sodium silicate is directly as a liquid. So we just took it this and mix both instead of using water. Okay, instead of using water, I used sodium silicate solution. So sodium hydroxide, which comes as a pellet, though we have to dissolve in the water. We use the water ratio as the standard is like 1:4 something ratio. We mix it. We make two solutions: sodium hydroxide solution, sodium silicate solution. So instead of water, okay, first I determine how much of water I required to prepare my CBR model. CBR, I hope you all civil engineers knows how to make CBR model. Okay. So to prepare the CBR model, we need the water content. Okay. Maybe 30%, 35%, 40%, whatever it is. So, for example, water is 35%. alkaline activator that's called sodium hydroxide and sodium silicate together is called alkaline activator. This alkaline activator also we determine by using the compaction test. How much of alkaline activator to mix it. Okay. And we got somewhere 35%. So 35% of solution mixed with the soil. Then we pick up the number. We didn't use the water. That's what we performed the geopolymer analysis. But if you ask me, sir, how practical this is in the industry, definitely is a big challenge. Okay, this is a big challenge. Geopolymer, not only in the geotechnical application, even in concrete, many places, geopolymer is not that easy to apply, but it gives a very good start. And there's a big term, right? Nowadays, people are using a big term called CO2 emission can be reduced by using a geopolymer concept. That's where we can go. If you want clear information, please. I'm sorry, I'm repeating the same thing, but you can get better information in my research paper where we have detailed explanation, and you can contact me at any point of time through my mail ID. Thank you so much. So there's one more question, Shabla. What is the reason behind high OMC in red? That's because of silt nature. The presence of high silt indicates the presence of definitely any material which has high silt will have the high OMC. That's obvious. Any from Dr. Gauss Peter sir is asking, tell me any advanced tests. Sir, advanced tests means there are so many advanced tests, but I think many institutional conference and papers accepts nowadays only if we have SCM, XRD, and FTIR. Okay, so advanced tests, I can suggest you can do SCM, XRD, FTIR is good enough, sir, where you can get enough information. SCM, scanning electron microscope, XRD, extra diffraction, and FTIR. I think this give you enough solid information. Okay. That's all. I think no more questions. Yeah. So if anyone have any doubts or further, you would like to contact me, like just mentioned. So given my mail, the chat box, if anyone is interested or if you want to know more about my research and research papers, you can mail me. Through mail, I'll respond as it is first. Yeah. That's all from my end. Thank you. Organizers, anything? Chaitanya, sir?
Sir, 1 minute, sir. 1 minute, sir. Some technical issue, sir. That's what. 1 minute. Please proceed. Sir, you can hear me?
Okay. Yes, I can hear.
Thank you, sir, for your expertise and passion for sustainable construction have provided us with invaluable insights. Your thought, analysis, and real-world examples have shown us the immense potential of this approach. I'm honored to express our heartfelt gratitude to you, sir, for enlightening and inspiring presentation on application of industrial waste in roads. The knowledge you have shared with us today will undoubtedly inspire us and explore and implement these sustainable solutions in our own projects. On behalf of KL University Department of Civil Engineering, I would like to extend our deepest appreciation for your time, sir. We look forward for more opportunities to engage with you, sir. Thank you.
Thank you so much. Thank you all for patient listening. And once again, thank you, KL University Management. Thank you so much to my friend Chaitanya sir. Thank you.
And regarding the feedback link, we'll post in 5 minutes. There is a technical issue.
Organizers, can I leave?
Yes, sir, you can leave, sir. No problem, sir. I informed the participants to stay for a link. For
Sure.
feedback link, you can leave, sir. Thank you, sir. Thank you so
Sure,
much.
sir. Thank you, sir. Thank you so much.
Participants, please wait. I am sharing the link. Within 2 to 3 minutes, I will share. You please